Wait, what am I doing here again? Oh yeah, I was gonna give a talk here. Yeah, I tend to forget things. I stand into the endlessness of my fridge. I leave home with that sense of incompleteness, but not being able to figure out what it was that I had to do before leaving. Nowadays, I realize that this is quite normal in a stressful life with a nice job, small kids, the like. You start to make silly mistakes because focus is just not what it always used to be. And the trick here is to help yourself out a little bit. And so I created something that probably all of you have created at the start of their programming story, a to-do app. Yeah. So my name's Henk. I work at Matter as an engineer, have been for a couple of months. And I've been using Rust for a while now for backend stuff, for embedded stuff, and I've been loving it. So much so that I try to share my enthusiasm in trainings and in creating educational material. I'm currently working on Rust Discovery book with a bunch of people, and I'm a maintainer of Teachers, the university course in Rust. So yeah, I work at Matter. The name probably rings a bell. We design and develop web applications for international clients. We mentor teams that develop apps themselves, helping them to overcome obstacles, work with new technologies, and ship out their results faster. And of course, we love Rust. Now, to-do apps are underrated. They serve as great examples for teaching programming languages, for instance, allowing you to go a step further than hello world. And you know, they help people like me through life. But to-do apps also have a downside. They need to be available, any place, anywhere, anytime. And I might not have my phone on me standing in the kitchen, or my laptop open while driving. That's actually illegal in my country. So what I need is a whole bunch of to-do apps, and that run on all kinds of stuff. Could be my phone, or could be my laptop, could be my fridge, or my car, or my database. But as I mentioned, though, I've got quite a full schedule. So I can't have myself recreating to-do apps for every platform all the time. And now I realize that this is a problem many a software engineer faces. How can I make the most of the code that I just wrote? No, of the knowledge that I gained. So in this talk, I make the case that Rust is what you need, preaching to the choir here. But that with Rust, I've got this superpower that allows me to write all kinds of software. That Rust allows you to tip your toes in software of all sorts. Be it in the browser, be it in the backend, or bare metal firmware. If you can do Rust, you can do anything. So let's build up a little bit of context here before we get started with creating this app on various platforms. So, a to-do app, how hard can it be? Raise your hands. What functionality can you typically find in a to-do app? Anyone? That's one. There's microphones. Yeah. Again, please.
Synchronization.
Synchronization. Okay. What else?
Add a task. Add a task.
Add a task. Yeah, that would be really nice. Exactly. Yeah. So basically, you would need some way of entering new items, store items, fetch them, view them. But you'd also need to delete items once they're done, right? And you need to reorder items on the list. And also, I like to be in control of my life and the things that I do. So my wife, or say my boss, should not be able to see the items that I've got on my list, let alone edit it. So we need some sort of authentication as well, right? So let's put that on a list. There you go. Now, we'll get started with something fundamental, defining a to-do item. So obviously, that should hold a string, right? Which describes what we need to do. And there we go. But what's missing here? Raise your hand.
Don't flag. if it's done. To mark a done boolean, something to mark the status of the agent.
Oh, right, whether it's already done. Yeah, could be. Yeah. I myself also thinking about something else, the priority on my list. So, but I've made the priority optional, as it can be inferred from the position inside some data structures, which probably you are already thinking all the time, such as a factor. And so I wrapped the to-do item in another struct that augments it with an index. Now, let's define behavior. So another question. What language feature does Rust support that allows you to describe the behavior of something without specifying the implementation? So just the behavior.
Traits.
Traits, there you go, that's right. So let's conjure up a trait that works for us. Let's call it to-do item store. And so here's a possibility. And as you can see, it's got a bunch of methods. I'm not going to bore you with each of them, but we've got methods to do all the things that we want with to-do items. And now we can implement this thing for a factor. And as you can see, a factor is basically a list, right? So it maps really well to this trait, and we can just basically forward the stuff to a factor. So now we have something that supports the functionality of our to-do app. Cool. Right. Now, as a software developer, I sometimes find myself using the terminal. It's a pretty cool piece of software, which allows you to do almost anything on your computer. And once you start using it, you quickly forget why that thing seems to be so scary for non-IT people. And as it turns out, Rust is a language that lends itself very well to writing CLI tools. So let's write a to-do list app for the terminal. And yeah, let's call it Irgendwann CLI in the spirit of this talk's title. So let's try out my little demo setup here. So you don't need to see all the details, but what I've got here is a command enum that just derives the clap traits, which allows me to specify the whole interface of this thing in Rust code, which I think it's pretty neat. And then executing one of those commands is just matching on that enum and forwarding the stuff to our store, which is backed by a factor. So let's go ahead and try this thing out. So cargo run, nothing. Okay, yeah, there we go. It's given us our API. Our interface already, so that's cool. Now let's go. Oh yeah, that's what's wrong. So let's fetch the current list of items using the items command. And does it work? Okay, yeah, that works, right? Because we didn't add anything. Now let's register something. Luckily, I've got I've got fish installed, which finishes my sentences. So I can just, register this very important item, register the thing, and then run items again. What? Did I already finish that then? What happened? Any idea? What's wrong?
No database.
There's no database. Ooh, yeah. So yeah, my factor is all gone up in smoke. Now, I could now implement some kind of file-based persistent storage using serde or something, or I could even pull in SQLite, but let's think a bit bigger here. It shouldn't matter from where I'm checking in. I should see the same list of items, from anywhere. Oh, whoa. What's that sound? That's the sound of a REST API coming up. So does anybody know what a REST is an acronym for? Does anybody actually know this?
Representational state transfer.
Very good, very good. Yeah, I had to look that up myself, which is interesting because I think about everyone here has written one of these things in their career somehow. Now, REST APIs often need to be able to hold to handle loads of data, and they might be subject to constant change, and they need to be secure, and they need to be easy to work on. So, another question. What kind of language, what language would you write your REST API in then?
You're always coming to me. Open API?
What kind of conference are we at? Rust, of course, people. Okay. Yeah, well, I guess, yeah, you're right. Technicalities. So there's a whole bunch of amazing web framings out there. In Rust, for instance, there's Rocket, which makes it very easy to write fast, type-safe, and secure web applications. And that one's pretty much batteries included. And then you've got ActixWeb, which is based on the actor model and is famous for being always very high in the Tech Empower's web framework benchmark. And then another one that's gotten pretty popular the last couple of years is Axum, right? You all know it. Part of the Tokyo project, which is basically a very thin layer on top of Hyper, which again is used by Rocket and some other web frameworks as well. And I like thin wrappers very much because they allow me to understand what is going on. So I'll go with Axum. And for persistent storage, yeah, we're going to just go with Postgres. It works for everything. And yeah, so the thing is going to be already quite professional. So let's create a simple REST API that exposes the functionality defined in our to-do item store trait. And let's do the old switcheroo again. And there we go. Now, I am just going to scroll through this code. And what I want you to focus on is how much code this is. And noting that we are speaking about a compiled and optimized language here. So this language is very, very efficient. But still, it allows you to write a very nice API server that has, cores, it has a bit of authentication, it has, all the things that we wanted. It has well, the database stuff I'm not showing here because, Postgres is weird about ordered lists, as is all SQL databases. But, this stuff is like amazingly ergonomic, given what this language itself can do. And I think that is so amazing. That is just something that we need to realize more, I feel. So that's that one. So let's give that a try, actually. Let's move back to the editor. So it should be already running in the background. And now I've got another function, version of our CLI that I won't bore you with that has an implementation of the to-do item store trait that is backed by a HTTP client, namely request. And so let's run the thing, cargo run register, for instance. Okay, and now that we cargo. Oh man, I can't type when people are looking. Please look away. And there you go. Get apple from desk was put at priority 0, which is, when we should start counting. Good. So this works now. Now we've got a cool CLI and we've got a cool web server. So what else can we do? Let's have a look. Right. So the cool kids nowadays, what they do is serverless. Power to them, because going serverless is the way of not getting sucked into DevOps if you just want to spend your time coding. And it's very easy to scale up as demand increases. But serverless is not cheap. So typically, you pay for CPU time and memory use. And so you definitely want to reduce those. So what do? Raise your hand. Use Rust. There you go. You're my favorite crowd. And, well, you're right, by the way. Using the amazing Cargo Lambda tool and the officially supported Lambda crates, setting up a Lambda function using, for instance, AWS is a piece of cake. So let's go through another quick demo, just to have a look at how small all this is. So I've got a For instance, I've got the register function, which is defined as one of the binaries, as maps very well to the serverless concept. And this just handles the register API endpoint. And as you can see, this thing is about 25 lines long. It relies on this actual support thing. Oh, no. Oh, there it went. Okay. Yeah, that was what was going to happen there, wasn't it? But doesn't matter. Yeah, there we go. So this thing is small. It handles the request, the register endpoint. And this is about 26 lines long, but it relies on this little piece of support code that I wrote. It is the first time that I wrote anything for AWS Lambda, so please don't hurt me. And here's another 100 lines of code. So this is, again, very easy, very short, very efficient, very cool, right? So that's serverless then done. So far so good. We've got a simple CLI, and we've got a bunch of backends, but not always do we have a terminal handy. And running curl commands is no fun when you're on your phone. So let's take this to front end. Can we make Rust run in the browser? Now, when it comes to WASM, the Rust programming language is always close. Not only is it trivial to cross-compile Rust to WASM, generating bindings to JavaScript and using browser APIs has become fairly easy with WASM bindgen crates or JSSys or WebSys. And you can easily expose your to-do app's functionality from a WASM module as a JavaScript class like this. There you go. You just slap on the WASM bindgen attribute everywhere, and you're set. Now I've left out the other implementation, the other methods for the trait, but you'll get it. And you can also very easily call into, for instance, the browser's fetch API from Rust like this. So look how we can even convert between JavaScript promises and Rust futures. Those will get polled by the JavaScript engine again. I think that kind of stuff is just amazing, and it's just so very easy to use. I think that's really cool. And also, the tools that I used to set this thing up is just trunk. Maybe you know about it. If you do, you know that it's just a matter of running your stuff, and it works. And it worked very well for me in the purpose of this demo. So let's give that a little try then, shall we? There we go. So let's refresh this thing. And now we've got our latest to-do item on top of the list. I can even, swap the thing around. And what's going to happen now is that my browser runs a bunch of JavaScript code, but that essentially forwards all the stuff to my WASM bindgen generated API. And that just works. It was like, this stuff was like so easy. Like, the hardest part about this was centering the div in the middle. So yeah. Okay, maybe the bar is not that high. WASM is an amazing piece of technology. So the web part in the name may make it seem like it's just suited for web stuff, but nothing is more wrong. Do you remember the slogan, write once, run anywhere? Well, WASM's got your back, because with WASI and other stuff, you can compile your code once and run it anywhere, from browser to server to unembedded, or as an edge function. But just the fact that this stuff runs in the browser, I think that means that Rust is cooler than, say, Java in my book. Now, speaking of embedded, you know what's really going to solve all my problems? Having my to-do list be part of the thing that I'm staring at. Now, imagine staring at your fridge and having the thing itself tell you what you were going to do. Now, no one actually seems to know what embedded is. Does it count if you've got Linux? What if I tape my phone to my dishwasher? Is that embedded? But I do think that stuff running on microcontrollers fits. They're often cheap, they're low power, they don't have much compute or memory available. And I'm talking bare metal here, so there's no runtime, no operating system, no nothing. Only the software that you put on there is being run. So, need networking? Do it yourself. Need a file system? Ask Jonathan Pellant, or, good luck. Need heap allocations? What's that? The embedded world currently mainly runs on C, but there's a new kid on the block, and it's Rust. To show you that with Rust we can write same code and that runs in limited environments, I went ahead and created a little to-do app that runs on this little BBC microbit. And now I am really going to ask a lot of favor from the demo gods, because I'm going to show you what that thing looks like. This little microbit over here. Okay, so this essentially is a board that has a little microcontroller on there, and has another bunch of cool stuff. But this matrix that you're seeing right here is a bunch of LEDs with which you can actually, put images on or scroll text. And the latter is what I'm going to be doing. Now, we'll of course have another implementation for our to-do item store trait, and that thing, as you can see, had async methods. So we'll need to have async on this board as well. And this thing cannot rely on TLS, for instance, for encryption. So it uses its own encrypted and signed message protocol, which it shares with the CLI for demo purposes, but it could share with the server to support TCP or UDP socket connections. So this here piece of code defines the data of our simple communication protocol that I'm using on this thing, and it's all in Rust. So it supports everything that we need to implement the to-do item store trait. And using SerDe, it is really trivial to send this stuff over the wire directly. Or you can put the payload in frames, which then can be encrypted and signed, like I'm doing in this case. So if my boss were to attach his oscilloscope to my wires, he'd be none the wiser. Now I'm going to actually try to show if the film works. It would be so cool. So let's see. Let's first switch to the editor. And there we go. So first I set up my CLI. And it has me pick a port. I pick the one that this microbit is connected to. And now I can just call cargo run on my microbit code. Okay, so it's now flashing. Cool stuff. And now it says I should press buttons. So I will now show you what happens if I do that. So here we go. Need to take it upright. And press. Yeah. I remember this one. So this thing is actually now connecting to our CLI. In real life, this thing could directly connect to a server as well. You can do anything. But what's cool here is that, again, our code is just, well, it's just high-level stuff. I mean, there is concepts that you need to learn about, obviously, especially for the board bring-up. But you can do, you can just await stuff in embedded code in Rust. Like that is such a high-level concept, just works, and it's very ergonomic. And I think that is just, amazing. Again, Rust is amazing. Now, I wouldn't say, oh, this is trivial, but just imagine how this would all work in C, for instance. You pull in an RTOS to keep your sanity, or you have some kind of code generator set up your projects. I mean, the bad kind of code generator. And pulling in dependencies is a real pain, whereas with Rust, it's just a matter of running cargo add. And doing concurrency on embedded, like we're doing with Embassy, I think is simply unmatched. So that already covers a whole lot of stuff. I've got plenty of ideas for other platforms to run Rust on, like natively on iOS or on Android with MakePad or Flutter Rust Bridge, or as an operating system, or as a database extension, or as a native Python extension, or as a Linux kernel module. But I think you get the point by now. So why is this awesome? Well, for some environments, yeah, you need to learn about the context that the code runs in. Believe me, I have experienced that when getting into embedded. You need to learn hardware, protocols, compiler and linker stuff. But at least, you don't need to learn a whole new language. You don't need to learn a whole new ecosystem. You don't need to figure out where to best find documentation or how that is structured. You don't need to feel depraved of functionality when going bare metal. You can write efficient code that can run about anywhere. You can have nice things. And that is on top of the whole Rust memory safety story, of course. Now, that's all nice for developers, but it's great if you're running a team of engineers too. Because imagine being able to hire someone, have them learn a little Rust, and then allow them to work on anything you can think of, within reasonable bounds, of course. But your engineers, they become like Swiss Army knives. You can hire engineers based on the domains that they fit. And you don't need to rely on the set of programming language that they have experience in. You can build your whole company on a standard language, and thereby standardize tooling, patterns, libraries across the whole organization. You can go beyond writing to-do apps. And that was it. Thank you very much.